So in this video, we're going to use something called the counting principle to determine the number of combinations for a situation. Now, the easiest way to learn the counting principle is actually to see a couple of examples. So here, let's read through. It says, in your closet at home, you have 3 pairs of pants and you have 5 shirts. How many different outfits can you design using these clothing items? So what I'm going to do here is I'm actually going to brainstorm, and I'm going to pretend that I'm going into my closet and I'm going to design some outfits. And I know that I start off by having to choose some pants. So I have 3 different pairs of pants. One pair might be leggings, one pair might be khakis, and one pair, let's say, is jeans. So I have 3 different pants that I can pick. Now, when I go into my closet, I also have 5 shirts, and all of these shirts can pair with my pants. So let's say that I have a red shirt, a blue shirt, a yellow shirt, a green shirt, and a pink shirt. So I have 5 different shirts. So what I notice here in this picture that I've drawn is I can do leggings with a pink shirt, leggings with a red shirt, leggings with a blue shirt, leggings with a yellow shirt, or leggings with a green shirt, which total 5 outfits with just the leggings. Now from here I can do the same thing with the khakis, and I can do pink, red, blue, yellow, and green. So I have 5 outfits that result from the khakis. And then I can repeat this process again with the jeans. I can do pink, red, green, blue, and yellow. And so I have 5 outfits with the jeans. So what I notice here when I look at this particular situation is I notice that I have a total of 15 outfits. Now, we can draw this out every time and find all of the different combinations, but what I notice here when I look at 15 is 15 is 3 times 5. And the counting principle is just that. If you know you're making combinations, you can multiply 3 times the 5 different shirts, and we'll end up with 15 different outfits. So let's take a look at another example and see if we can apply this same multiplication trick to that. So here we have a second example, and it says, in her pantry, Sophia has 3 different options for soup, 2 different options for crackers, and 4 different options for desserts. How many different soup, cracker, dessert combinations can Sophia make? So here's Sophia, and she's got soup 1, soup 2, and soup 3. So she can choose one of 3 soups. And then from here, she can choose one of 2 crackers. So we have cracker 1, cracker 2, cracker 1, cracker 2. So from here, she can now choose one of 4 different desserts. So we have dessert 1, 2, 3, 4. Dessert 1, 2, 3, and 4. Then dessert 1, 2, 3, 4. I'm going to kind of go a little more quickly here. Dessert 1, 2, 3, 4. Dessert 1, 2, 3, 4. And dessert 1, 2, 3, 4. Now let's go through and count the number of different combinations we have. So here we have soup 1, cracker 1, and then 1, 2, 3, 4. Cracker 2, 5, 6, 7, 8. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So here we have a total of 24 different combinations. Now on the previous slide, we noticed that we could just multiply the 3 times 5 and get our 15. So let's see if this works again. So we had 3 times 2, which would give us our 6. But then we had another level added on with the 4, which gives us a total of 24. So the counting principle allows us to multiply by the number of options in each slot in order to determine our total number of combinations. So now let's apply this principle to a more complex example. So here it says a password is 4 characters long. So we have 1, 2, 3, 4. The first two characters are letters, and the second two characters are numbers. How many possible combinations are there? Now, it might seem like we can't do this because we don't have any numbers, but we actually do. We know how many options we have for each slot. So this first character in our password has to be a letter, and let's just assume for this problem that it doesn't matter if we do capital or lowercase. So here we have to think through how many possible letters do we have to pick from. Well, there are 26 different letters. So our first number here is going to be 26. Then our second number is also 26 because we could pick the same letter back to back. We could do A and A or F and F. That would still be allowed. So in our first two slots, we have 26 possibilities. We could pick one of the letters for the first slot and one of the letters for the second. Then from here, the number of numbers on our keypad, I know you might think is 9, but is actually 10 because we go from 0 to 9. So here we have 10 slots for a number and then 10 again for a number. So we have 26 options for the first slot, 26 options for the second slot, 10 options for the third slot, and 10 options for the fourth slot. So what we can do now is we can use this counting principle and we can multiply them together. So 26 times 26 times 10 times 10. And what we find is we have 67,600 possible combinations. So this kind of shows you the power of using letters and numbers and symbols and making passwords long because you make it so it's a very difficult thing to crack. Now, this last question here says, what is the probability that you guess the right combination? Well, probability, remember, is that it's probably that we guess the password. Probability is the number of successful attempts over the total. If you get one guess, the probability that you are successful is there's one correct password, and there are 67,600 possible combinations. So the probability that you guess correctly is 1 over 67,600.